page 18 of Applications of Calculus. Find the area enclosed by the function y equals f of x in the x-axis, and here's the function x cubed minus 9x. I guess the first thing that we should do is kind of draw a sketch. Remember, x cubed function kind of looks like this, right? So this x cubed function, when does it intersect the x-axis? We can find that by setting it equal to 0. Of course, we could do second calc 0 on the calculator. This is not too bad. We can do this without the calculator. We can factor out a common factor of x, and then inside it would be x squared minus 9. When does that equal to 0? It's equal to 0 when x equals 0 or when x equals plus or minus 3. So I think that it would look like something like 0, -3, and +3 would be the three places that the function crosses. So you can see that there's this section here between the curve and the x-axis, and you have this section here between this curve and the x-axis. And you have to be careful. You can't just integrate from -3 to 3, because if you did, this positive part is going to cancel out with the negative part, and you're going to get 0. So there's a couple ways you could do this, but one of the ways is you could just do half of it and then double the area. The other is you could do the two areas separately and then take the negative of this area. So this area here on the left we would do by integrating between -3 and 0. Sorry, this is 0 in the middle. And then we would put the function inside, right? And that would be this part here. And then this right part we would do 0 minus the function in order to get a positive integral, and then we would integrate from 0 to 3. So either way is fine, and then we would add them together. But you know, as we can see from the graph that we did here on the calculator, it's symmetric, right? So it's going to be the same thing here as here, so we could just double one of them. So let's do this one only. So x to the 4th over 4 minus 9x squared over 2 bracket -3 to 0. If we put 0 in here, we would just get 0. And then we would subtract. If we put -3 in there, we'll get 3 times 3 to the 4th is 81 fourths. Minus 9, -3 squared is also 9 over 2. So we would have -81 fourths plus, because the negative is distributed, plus 81 halves, which would be 2 times 81 fourths. So if I add these together, I get 81 fourths. So 81 fourths is the area of this left side, and if I want to double it to get the complete thing, I would do 81 fourths times 2, which would equal 81 halves. So for the whole thing, it's 81 half. Okay, that's my final answer for the entire function. Number 11, explain why the total area shaded is not equal to integral from 1 through 7 f of x dx. So the problem is these two parts are positive and this part is negative, and they're going to cancel each other out, right? So you can't just integrate the whole thing from 1 through 7 in one shot. Write an expression for the total shaded area in terms of integrals. So we need to break it up into this section, and this section. The sections 1 through 3 and 5 through 7, those can be straight up integrals. The integral from 3 to 5, we need to take the inverse of it so that we make sure that each section is positive. So I would do 1 through 3 f of x dx. That would be this first section. Then for the second section, I would do 3 through 5, 0 minus f of x dx, and that would be this middle section. The other way you would do is you say, oh, okay, I'm going to do 3 through 5 f of x. I know it's going to turn out to be negative, so I'll just put a negative here. Either way, it's fine. The reason why I like doing this is because I like to say, okay, this part that's underwater, I'm going to do the integral of this top function, which is y equals 0 minus the f of x function. So that's the reason why I do it this way. Finally, I'm going to add 5 through 7 f of x dx, and that will be the last piece, which is positive. So this is fine for part B, total shaded area. Okay, number 13. Find correct to 3 sig figs the areas of the regions enclosed by these curves. So these are, we can't do it without the calculator because we need to find the intersection points using the calculator. So let's do this first one. We're going to type in these two functions into the calculator. I'll be right back. I'm going to pause while I do. Okay, I'm back. The first function, e to the negative x squared. The second function, x squared minus 1. Now I'm going to graph it, and then we'll see that e to the negative x, and e to the negative x squared is a hump. It's a normal distribution, and x squared minus 1 is a parabola, slightly lowered. So this area in between, in order to integrate that, we're going to have to find the intersection points. So we'll do second calc intersect, number 5. And then we'll move the cursor slightly to the left, and then we'll just hit enter, enter, enter for first curve, second curve, guess, and it is negative 1.13. You can see that it's symmetric, right? So we have this shape, and this one is negative 1.13. Of course, this one would be positive 1.13 because it's symmetric. If we want to find the area in between the two, there's a couple ways to do that. One is we could make a new function, which would be e to the negative x squared minus this one. We could actually do that by doing y1 minus y2. So we could say second, where's vars? Vars. No, we don't even need second. It's not second. It's just vars. Vars. Y vars function y1 minus y2. Vars y vars function y2. So y1 minus y2, we've made a third function called y1 minus 2. And then we could just integrate this third function. Now when we graph it, the third function is going to look kind of weird. It'll be like a function which is the blue function minus the red function. Okay, so it's this black function here. So I can find the area between the blue and the red function by integrating underneath the black function. So what I'm going to do is I'm going to do second calc integrate, which is 7. And I'll just put in my limits. So negative 1.13, enter. And then I put positive 1.13, enter. And, oh, I integrated the wrong one. I need to integrate the black one. Okay, I'm going to integrate the black one. So second calc integral 7. And first thing I need to do is I need to select the function y3, right? So like I do that by using the up down arrows. So let's say I went up, and then y3 equals y1 plus minus y2 is selected. Now I need to type in the limit 1.13, and then my positive upper limit is 1.13. Okay, now it's going to work, and it'll color in the black. There we go. So the answer is 2.88. 2.88. So it's actually this area here, but the way that it shows up on the screen is they take this little red area here and they deform it into this black area, and then you calculate it using this black area. All right, let's do the next one. So for this one here, we're going to do the exact same thing. We're going to graph these in the calculator first so that we can find the intersection points, because that's the first step. All right, so I'm just going to turn off y1 minus y2. We might use it later, so I'm not going to delete it, but I'm just going to toggle it by hitting enter, and now it's not going to show up anymore. And I'm going to type in these two functions. X to the x, of course, we type it in by doing x circumflex x, and then in the next row I'm going to do 4x minus 1/10 x to the 4th. So 4x minus 1/10, which is the same thing as 0.1, x to the 4th, which is x caret 4. Okay, graph. And so the blue one is the top function and the red one, or the blue one is the first function and the red is the second function. Okay, so we want this nice little fish shape here. So we can actually graph that using the black function. So the black function, which is here, combines the two functions in a subtraction. Okay, so actually, so the red function is higher than the so y equals x to the x is my blue function, right? Oops, my blue function. And then the second one is the red function. Oops. First one is my blue function, and the second one is my red function. So the red function is on top here. So actually I need to do y2 minus y1 when I do the integral, right? So when I do this integral, I need to change my third function. I need to do y2 minus y1. So let's do that. y2 minus y1 vars, y vars function y1. Okay, now I can turn off my other two functions, make it a little bit easier to find the integral. Okay, so now I'm going to integrate under the black function like I did before. Oh, I forgot to do the intersection points, darn it. Okay, let me go back. I need to do the intersection. I need to find the limits, right? Okay, I'm going to turn off y3. Okay, and now I'm going to find the intersection points between the blue and the red function. Okay, second calc, intersect 5. I'm going to move the cursor a little bit over to the right, and then I enter, and the first intersection point is 0.183. So I integrate from 0.183, and the next intersection, let's try that, second calc, intersect 5. We'll move the cursor over closer to the second intersection point, hit enter 3 times, and the second intersection point is 2.27. And now we're going to do y2 minus y1. Okay, so let's do that. First of all, I'm going to turn off the display of the first two functions, and I'm going to turn on the display of the third function. This is the y2 minus y1 function. It doesn't look like y2 or like y1. It's a combination of the two from subtraction. So I'm just going to take the integral of this space here. I do that by doing second calc 7. And then I type in the lower limit, which is 0.183. Enter. And then I type in the upper limit, which is 2.27. Enter. And then it should color in the black part, and the answer is 4.97. Okay. Last of all, number 15. The shaded area is 1 unit squared. Find b correct to 4 decimal places. So this is one of those backwards problems where they give us the answer, and we don't know the limit. So if we're going to integrate this, we need to integrate from 0 to b. And the function is square root of x, right? For some reason, they give us the answer, which is 1, but they didn't give us b. So how are we supposed to do this problem? Well, they want us to do everything, but when we plug in the limits, we don't have a number. So let's see. Remember, square root of x is x to the 1/2. So actually, I'm taking the integral of x to the 1/2. I'm going to leave the right side as is because I can't do anything with it. So I'm going to take the integral of x to the 1/2. It would be x to the 3/2 divided by 3/2, right? I'm using the power rule. Bracket 0b. Then I plug in the b, and then I plug in the 0 and subtract the 2. So this would be b to the 3/2 and then dividing by 3/2 is the same thing as multiplying by 2/3, right? Minus 0 plugged in, which is just 0. So now I just set that equal to 1, and then I just solve this. This is just an algebra problem now. It's not even calculus anymore. Multiply both sides by 3/2, so I get b to the 3/2 equals 3/2. Then I have b to the 3/2 equals 3/2. So how do I find what b equals? I do b to the 2/3 power. If I do b to the 3/2, oops. If I do b to the 3/2 to the 2/3 power, and then I also take the 2/3 power of the other side, then I will have b, because like if I do the 3/2 power to the 2/3 power, if I multiply them together, it gives me b to the first, right? And then the other side is 3/2 to the 2/3. I can do that on the calculator. 1.5, which is 3/2, caret to the 2/3. 1.31. So the answer is b is 1.31. I could also do this by guessing, right? I could go to math, and I could go to math, and then I go up, and then I could do FNINT, and then I could type in this whole problem. I could put 0, and then I could put square root of x here, and dx, and last of all, I could go up here and I could guess a number to put in here for the upper limit. I could put, for example, 1. And then I just hit enter to see what I get. And I get 0.66. I'd like to make this into 1, so I just, instead of 1, I put something bigger, like 1.5, right? And that'd be too big, and then I take it down to 1.25. And then eventually I would get the answer using the calculator and guessing. Okay, so it's not that hard to do. You don't have to do algebra as long as it's a paper 2 problem, but probably it's going to be a paper 1 problem because they want to force you to do it with algebra like we just did there.